Okay, thanks. We can proceed now. That was really the talk of Kenji Kawai from University of California,
Yes.
Santa Barbara.
Yes.
And the title is Subducted Continental Materials Around the Bottom of the Mantle Transition Zone. Please.
Thank you. We want to discuss the subduction of continental crust to the Earth's deep interior, and we want to propose a new hypothesis. So, this is a picture of the Earth, our mother planet. The granite and the continent is existence of continent granite is one of the most typical features on Earth. So, classical paper by Campbell and Taylor, 1983, denoted that the Earth, the only inner planet with abundant water, is only planet with granite continents. So their title is no granite, no water, no granite. So and also, as Shige said, no granite, no life. So granite is important for origin and evolution of life also. And I'm a geophysicist, so I'm interested in this feature. Continental crust contains a large amount of incompatible element and radioactive elements. So, and also the fate of continental crust, which is continental crust is which includes large amount of radioactive elements. So affects the Earth's evolution this way. So, in order to understand the evolution of the Earth, it is important to understand the fate of continental crust and granite. So, the continental growth is important. This is there are many models for continental growth. And this is, as Shige shown by Shige, this is Reno 2008. This black line indicates that the existence of present granite continental crust on the surface. So the discrepancy of this line and other model indicate missing of continental crust on the surface. And also, recent geological studies proposed new concepts of consumption process of continental crust. First one, left-hand side is tectonic erosion, and right-hand side is arc subduction. And tectonic erosion is like that, hanging wall containing consistent of continental crust is eroded by subducted slab and carried to the Earth's interior through the granitic subduction channel here, subduction channel. So the sustainability of subduction channel is important for understanding the fate of continental crust. And also, as shown by Shige, Isbonian arc is collided to the Japan island, and there is no accretion to the Japan island. So almost all the Isbonian arc is subducted to the deep Earth mantle. So this is a review cartoon of showing consumption process and production process of continental crust. So green indicates production processes of continental crust, and red is consumption processes of continental crust. So the amount of continental crust and production as consumption is balanced. So a large amount of continental crust must be subducted to the Earth, to the mantle. And also, Irifune et al. 1994 studied density of continental crust. So they indicate that continental crust is not denser up to 270 kilometers, at which calcite stishovite phase transition occurs. So it is important to study how to carry a continental crust to this depth. So purpose of this study is to understand how the buoyant continental crust is subducted, and where the continental crust is subducted, and how much the continental crust is subducted, and how the subducted continental crust affect the Earth's evolution. So due to limited time, I will omit the details, but I will show these results. First, we consider subduction channel like that here and here. Sorry, and subduction channel. We compute granitic subduction channel using one-dimensional model perpendicular to the slab. This is and we study and channel thickness of subduction channel is D here or here, and we estimate the thickness of subduction channel for at each depth. Parameter used in these studies are shown here, and we compute finite difference methods and estimate the thickness of granitic subduction channel. We use density profile like that. This is Irifune et al. And Wu et al. And this is continental crust densities. And we use subduction temperature profile of slab temperature. So we calculate, we obtain sustainability of subduction channel. This is result. This is vertical velocities, and this is distance from the slab, and up to this is up to thickness of 2,500 meters. Downward flow increases as granite layer becomes thicker. But when the thickness of 4,500 meters, upward flow occurs. So this indicates that subduction channel is not sustainable. So from this result, we estimate the maximum volume of continental crust to the 270 kilometers depth. So we use length of subduction zone at present, and we use slab velocity like that. So and we use thickness of subduction channel, and we can obtain 2.5 cubic kilometer per year. So and also Clift and Hartley in 2007 estimate 5.0 cubic kilometers per year of granite is subducted to the by many construction processes. So this indicates that half of this volume can be subducted to 70 kilometer depth. So next we want to estimate the amount of continental crust briefly. And this is the first study. So we simplified earth and granite composition as follows, like that. So albite quartz system of high pressure mills of composition of albite quartz system is jadeite and calcium chloride phase and stishovite. So we compute density and elasticity via our initial calculations. So this is a result of elastic properties of TTG. And we first compute each elasticity and density for each mineral, and then we took Hill average and obtained elastic properties for assemblage of TTG. So we compute bulk modulus and shear modulus, and density. So we can obtain the elastic velocities, and also we can obtain the elastic velocities of TTG assemblage. So this indicates that stationary is very fast, and J-rate dissociation produce large velocity jumps here, like that. So next we compare the elastic velocity and density of TTG with those of pyrite composition. And this is a result, and TTG is this here is in this depth range, TTG is denser than pyrite composition. So TTG is moving down to the base of the mantle transition zone here, and TTG is very fast here in the mantle transition zone here, and TTG can produce large velocity jumps as well as post-spinel phase transitions. So, and post-spinel and post-J-rate phase transitions have negative and positive Clapeyron slope respectively. So next, as a first step, we want to estimate the amount of continual crust in the mantle. So since the classical paper by Anderson and Bass, 1986, the velocity of seismological observations such as PLAN or AK-135 is faster than pyrite composition here. And also theoretical studies and experimental study suggested that also PREM is faster than pyrite composition. So so previous studies interpret this discrepancy as temperature 400 Kelvin decrease or layering of Hasbagite. As for temperature, it is difficult to explain why it is cold only in the lower mantle transition zone in whole Earth. And as for chemical heterogeneity, Hasbagite can produce fast anomaly, but it is less dense than the surrounding mantle, so it cannot be stable. And as for basalt, this is denser, but